Hello viewers, in today's class we are going to discuss one important concept from three-dimensional geometry, right? And here we are going to discuss the concept of intersection of lines by solving a problem, right? So let us first read the problem. So here we have to find the point of intersection of these two lines, right? So here we are given the equations of two lines, right? And we have to find the point where these two lines intersect, right? So in three-dimensional geometry we see that two lines intersect if they are coplanar, right? So coplanar lines always intersect, and here we have to find the point of intersection, right? So what we will do here, we'll first find the coordinates of the general point lying on these two lines, right? So let us call this line as L1, and let us call this line as L2, right? And suppose this is the first line, say L1, and this is the second line L2, right? And this is the point of intersection P, and we have to find the coordinates of this point P, right? So here we'll find the coordinates of the general point. So what we will do, we'll here write a parameter or a real number, say lambda, right? So here lambda is a scalar, and here also we'll write a scalar, that is mu, right? Where lambda and mu are both scalars, right? So they are real numbers. So here let us first take the line L1, right? So here we have x minus 1 over 3 is equal to y minus 1 over minus 1, z plus 1 over 0 is equal to lambda, right? So if we inspect this equation, we see that this line L1 has the direction ratios 3 minus 1 0, right? And this line passes through the point 1 comma 1 comma minus 1, right? So from here we'll form three equations in x, y and z, right? So first we'll take x minus 1 over 3 is equal to lambda. We'll equate this term to lambda, then we'll equate y minus 1 over minus 1 to lambda, then z plus 1 over 0 is equal to lambda, right? And from here we'll find the coordinates of x, y and z, right? So x is from here, this is 3 lambda plus 1. From here y is minus lambda plus 1, and from here z is 0 times lambda is 0, and so we have z is equal to minus 1, right? So from here what we will get, z plus 1 is equal to 0, so z is equal to minus 1, right? So the coordinates of the general point lying on this line L1 are given by x comma y comma z, and these coordinates are 3 lambda plus 1, then we have minus lambda plus 1, and then we have minus 1, right? So here the x and y coordinates are they depend on this scalar lambda, while this z is an independent coordinate, right? So similarly we can take this line L2. So here we have x minus 4 over 2 is equal to y over 0 is equal to z plus 1 over 3 is equal to mu, right? So again, if we observe this line L2, we see that the direction ratios of this line L2 are given by the denominators. So here we have 2 0 and 3, and this line passes through the point 4 comma 0 comma minus 1, right? And again we'll form these type of equations for this line L2, right? So we'll have x minus 4 over 2 is equal to mu, y over 0 is equal to mu, and then z plus 1 over 3 is equal to mu, right? And from here we'll form the equations in x, y and z including mu, right? So from here we'll get x is equal to 2 mu plus 4, and from here 0 times mu is 0, so y is equal to 0, and from here z is equal to 3 mu minus 1, right? So the coordinates of the general point lying on this line L2 are given by x comma y comma z, that is equal to 2 mu plus 4 comma 0, and then we have 3 mu minus 1, right? So here these two lines L1 and L2 intersect. It means the lines are coplanar, and here when we find the point of intersection, it means there must be some common value of lambda and mu for which these two coordinates must coincide, right? Because this point P lies on this line L1 as well as on the line L2, right? So for some value of lambda and mu, these two coordinates must coincide, right? So it means this coordinate must be equal to this coordinate, right? Because this point of intersection is a common point between the line L1 and L2, right? So here what we will do, we'll write 3 lambda plus 1 minus lambda plus 1 minus 1 is equivalent to, or it coincides with this coordinate, right? So here we can write 2 mu plus 4, then we have 0, and here we have 3 mu minus 1, right? So now if we compare these two coordinates, this is the x coordinate, this is also the x coordinate, so we can write 3 lambda plus 1 is equal to 2 mu plus 4. Then we can equate the y coordinates, so minus lambda plus 1 is equal to 0, and then we can equate the z coordinate, that is minus 1 is equal to 3 mu minus 1, right? So here we see that if we take this equation, we get lambda is equal to 1, right? And if we see this equation, this minus 1 and this minus 1 get cancelled, and we are left with 3 mu is equal to 0, so mu is equal to 0, right? So we have obtained lambda is equal to 1 and mu is equal to 0, right, from these two equations. So now if we substitute lambda is equal to 1 and mu is equal to 0 in this equation, we see that this equation gets satisfied, right? See, the right hand side is 3 times 1 plus 1, and the left hand side is 2 times 0 plus 4. So this is 3 ones are 3 plus 1 4, and here we have this is 2 times 0 0, that is 4, right? So both the sides are equal for lambda is equal to 1 and mu is equal to 0, right? So this also suggests that these two lines are intersecting, right? So now to get the coordinates of this point P, we can take lambda is equal to 1 in this coordinate, right? So if we take lambda is equal to 1 here, see what we will get. 3 times 1 plus 1, here we'll get minus 1 plus 1, and here we have minus 1, right? So this is 3 ones are 3 plus 1 4, this is 0, minus 1 plus 1 0, and here we have minus 1, right? So the point of intersection is 4 comma 0 comma minus 1, right? So either we can find out the coordinates of this point P by taking lambda is equal to 1 in this coordinate, or we can take mu is equal to 0 in this coordinate, right? So here if we take mu is equal to 0, see what we will get. We'll get 2 times 0 plus 4, then we have here 0, and here we have 3 times 0 minus 1, and this is 0 plus 4, that is 4, this is 0, and this is minus 1. So we again get the same coordinates. So the coordinates of this point P are 4 comma 0 comma minus 1, right? So we were